Now, y equals mx plus b is fine, but we don't always know the y-intercept. Sometimes it's another point we know. So for that reason, we have our point-slope formula. It really is basically the slope formula rearranged. I mean, slope is y2 minus y1 over x2 minus x1. If we were to multiply by the denominator, we'd get y2 minus y1 is equal to the slope x2 minus x1. And all we're saying is, well, look, one of these points, we're just generalising. So instead of y2 minus y1, I've got y minus y1, and so on. So as long as I have a point and a slope, I should be able to find the equation of a line. So we get an equation like this. Goes through 2 points. That's all right. All I need is a point and a slope. I've got a point. Slope. Oh, damn. Haven't got a slope. Aha. But we have a formula that will allow us to find the slope. So first thing we do, find the slope. In this case, it works out to be -2. I have a point. I have a slope. Point-slope formula. Doesn't matter, of course, which point I use. Either one will work. Expand out. I've put it in general form. It doesn't really matter which form you put it in, unless they ask specifically, I guess. Find the equation of the line passing through 2, -3, and is parallel to 3x plus 4y minus 5 equals 0. Okay, I need a point. I need a slope. I've got a point, 2, -3. Slope. They've told me it's parallel to this line. So if I can find the slope of this line, I'll be okay. So let's put it into y equals mx plus b form. I can now see that the slope I want is -3/4. Okay, point slope form. Multiply out, and I get our line. That's the long way of doing it. There's a quicker way of doing it. If it's going to be parallel to 3x plus 4y minus 5, have a look at the answer. The coefficients of x and y will always be the same. So I can say, well, hang on, I know that this line will be 3x plus 4y plus some constant number. I just got to work out the constant number. Well, I know a point that's on the line. So I can substitute in that point, and we can work out k, and surprise, surprise, there it is, k ends up being 6. There's my line. That's a quicker way of doing it. So if the line they've given me is in general form, I'll just match the coefficients and work out what that constant number is going to be. Perpendicular, you can do a similar thing, but let's do it the long way first. So we'd say, oh, I've got a point, I need a slope. It's perpendicular to this line. So if I find the slope of this line, 9 on 4, I know the one I want will be the negative inverse. So I want -4 on 9. Point slope formula, expand out, bring everything to one side. Have a look at the coefficients this time. It was 9x minus 4y, it's now 4x plus 9y, because it's the negative inverse. So the coefficients swap around and the sign changes. Not both signs. And that's another good reason why we make x positive, because if we leave x positive, then we know, okay, the sign on y will just change. So I know then, if this is perpendicular, it was 9x minus 4y, so my line should be 4x plus 9y. Just got to work out the constant. Sub in the point, and what do you know? K is -60. So again, a quicker way of doing it, right, rather than, okay, let's work out the slope, etc., etc. We talked about 3 points being collinear before. So 3 points being collinear, all 3 points lie on the same line. The reverse of that is when 3 lines are concurrent. When 3 lines go through the same point. So how do we prove that? Okay, so I've got 3 lines, call them L, M and N. I'll just pick any 2 of them, find the point of intersection, so solve them simultaneously. I've picked L and M. Now, that answer, if I substitute it into N and show that it also lies on that line as well, and then we know it has to be on all 3, because we know it's on N, and it's the point of intersection of L and M, therefore, got to be on all 3 lines. So that's how we would prove something is concurrent, or 3 lines are concurrent. Dat is jouw